Okay, chapter 4, part 3. So the lecture note is available in the Google Classroom. Okay, so we're covering fluid dynamics, the last part. Okay, recording, right? Okay. So we will see some application, okay, and some calculation for Bernoulli's equation. Okay, for your information, for test, for your midterm test, so no calculation question. Okay, all theory. Okay, so I tak bagi calculation. Okay. So this subject memang I tak tanya banyak. So it's mostly more on what I discuss in the class. Okay, so application of the Bernoulli's equation. Okay, the first one is a pitot tube. Okay, so pitot tube adalah it's a velocity measuring device. So you can see, So you can see here. So you have a setup, okay, which measure the stream of uniform velocity. If you can see, you have a streamline. 1, 2, 3, 4, 5. Okay, so it is going. So this is a blunt body. Okay, ini adalah satu permukaan yang kasar lah. So kalau dia bergerak dari point 1 ke point 2, so at this point dia akan berhenti. So it will completely stop this point. Ataupun dia akan follow the body lah. But here it will follow the shape of the body, tapi dia takkan kena dekat blunt body. So only at this point it will be stick to the blunt body. Okay, so you can measure from this point to this point. So you akan ada satu sensor dekat sini lah, in order to detect the measurement. So that is what we call as pitot tube. Okay, so at that point 2, velocity is 0. Dekat point ni velocity akan 0. So based on this, so yang ni ada velocity, yang ni velocity 0. So you can just replace here and you can find. Okay, so that's how. So in Bernoulli's equation and continuity theorem, so you need to find so yang ni adalah general equation. So you need to make from the application, you kena tahu yang mana you kena jadikan dia kosong. Selepas yang ni, so katakan U1 jadi kosong, Z1 jadi kosong. So this whole thing akan jadi kosong. So at the end you akan dapat macam ni, simplify. So this equation is general, but equation yang you akan jadikan is based on the application ataupun information yang you dapat dari gambar ataupun ikut application dia lah. So not all the application you will use all these things. Sebab tu you kena tally dia dengan Bernoulli's equation together with continuity equation in order to find what are the simplified version of your equation. Kalau you dah dapat simplified version, then only you can find what is P1, what is V1. Sebab you kena jadikan something kosong dulu. So the information you dapat dari your gambar lah. So macam dekat sini tengok, Z1 sama dengan Z2. So kalau sebelah sini Z1 dengan Z2 adalah sama, you boleh cancel, jadikan dia kosong, you boleh buang. So, sebab tu dekat sini tak ada Z. So macam tu lah. Okay, so normally you will deal with dynamic pressure. Yang kita tengok tadi, dynamic pressure is related dengan U adalah velocity. Okay, so dynamic pressure always will have, so to this increase the pressure which bring the fluid to rest, is called the dynamic pressure. So maksudnya dia bergerak, tapi waktu dia kena something from opposite, dia stop. At that point, so you are measuring as a dynamic pressure, so pressure at the movement. So ataupun kita selalunya akan convert dia jadi dynamic aid. So H equals to P over rho G. So kalau you ganti yang ni dalam ni, so you akan dapat yang ni lah. Tapi selalunya dalam equation, in calculation or what, in your final exam, kita tak akan gunakan aid, kita hanya gunakan pressure. So just highlight this lah. So yang ni just boleh ignore, just for your information. The dynamic aid and your stagnation aid is just for your information. So kalau you nak gunakan dalam calculation nanti pun hanya dynamic pressure and also stagnation pressure. And the equation saya akan bagi dalam appendix. So you no need to memorize. So you try. Kenapa saya bagi equation dalam appendix? So kalau you tak tahu jawab, at least tulislah some equation dari appendix. At least saya boleh bagi 1 mark. Just to tolong you. Another thing, you no need to memorize everything. Because this is not a memorizing subject. You baca semua teori, you pergi ke exam, you muntah balik. So that is not this thing. So here I am giving you knowledge, I will test your knowledge. Okay, based on apa yang I explain. Sebab itu I bagi you video. So if you cannot attend the class, so you cannot come to class, so at least listen to the video. You have some resources for you to refer. So jangan, I still experience this. Tengah malam, 1 AM student message tanya. So janganlah. So at least stop until 6 o'clock. I know you all study at night. So keep the question for the next day morning. Okay, so jangan message me at night. So first thing, pergi refer dekat video. Sebab I dah bagi explanation. So kalau tengok dekat video still cannot understand, try your ask your friend. Then if cannot, then only you come to me. Okay. So there are two things. So one is dynamic pressure, stagnation pressure. Stagnation pressure adalah total pressure. So kalau you tengok, so this is your dynamic pressure, this is your static pressure. Static pressure selalunya one value. Okay, P1 sama dengan 10. So it's a static. So dynamic dia selalunya berkaitan dengan your velocity, which you can calculate using half rho U1 square. Okay, so that is your stagnation pressure. Okay, so the blunt body stopping the fluid does not have to be solid. Okay, so whatever that is stopping, tadi kita tengok kan, so ada point 1 and point 2, it kena dekat blunt body. So that blunt body, it not necessarily must be a solid. So it can be a static column of fluid. Maksudnya there's something static in terms of fluid. It can be air or it can be liquid. So which is a static liquid. So even that can be a blunt body. So it not necessarily must be a solid. Okay, so if you see, this is a piezometer. So you have a piezometer in order for you to measure the dynamic pressure, and you have a pitot tube. Okay, so if you see here, so you are measuring, so the water is flowing dekat sini. So when this thing is entering, so kalau ada velocity, air ni akan naik, because the particle is moving and it will go up. So dekat sini pun dia akan ada kenaikan. So you akan measure the difference between the piezometer and also pitot tube. So you can measure the height from the flow. Okay. So using the above theory, we have the equation for P2. Okay. So P2. So how you get this? Because less information here. But these are some things that you can get from your Bernoulli's equation. So no need to get confused. So you just highlight this. V1 equals to square root of 2g H2 minus H1. So that is one formula that you will use in your calculation. Okay, if given a calculation question. Okay, so just highlight yang ni lah. So it's just a derivation from this, you can get this. So we will only use this in your this kind of pitot tube application. So the expression for velocity obtained from two pressure measurement. So you have the two pressure here and pressure here, and the application of Bernoulli's equation. So you apply Bernoulli's equation and you can find this formula. Okay, so try this example. Okay, kalau ada exam ini adalah contoh soalan yang can be given, okay, in your exam. Okay, so for those who just came, okay, untuk test 1 nanti, so test 1 saya tak buat. This week banyak exam, banyak test. So sebab tu saya tak buat. So at least you ada 1 more week. So if you study lah for that 1 week during your midterm break, so try to study, and once you are coming back in week 8, sekarang week 7, next week is not counted, the following week kita akan ada midterm test. Okay, we will have midterm test. So actually quiz supposed to be after midterm, after midterm break. Minggu ni sepatutnya test, tapi saya tak bagilah sebab chapter 5 pun tak cover lagi. Okay, chapter 5 saya akan cover dalam add puzzle, so you listen to the videos. And as I said, for your midterm test, so only theory, tak ada calculation. Okay, so theory, so whatever we study in the chapter 1 until chapter 5 will be tested. Okay, so try this question. In water treatment plant, it is required to monitor the maximum velocity in the water mains. A pitot tube is inserted in the center of the pipe and connected to 2 piezometer tube. Okay, macam tadi ada 2 piezometer tube. If the differential pressure 8 is 250 mm, estimate the velocity of the flow. Kalau dalam soalan dia bagi tahu macam ni, differential pressure, maksudnya is between one point to another point. Macam dekat sini H2 to minus H1. Differential maksudnya dia akan minus, so dia dah bagi dah siap. So you tak perlu ada nilai H2 dengan H1 then you minus. So kalau dia bagi tahu differential pressure, meaning dia dah minus dah, dia dah bagi dah terus. Okay, sebab itu dekat sini 250 mm. So here H2 minus H1 you terus gunakan 0.25 because it's in meter. Okay, so punca kuasa 2G 0.25. So you boleh cari terus V1 equals to 2.21 sebab V2 adalah kosong. Sebab dia dah stop. Okay, so you boleh cari terus. Senang kan? So you just remember this formula. Tak perlu memorize pun, saya akan bagi dalam appendix. Okay, you just need to know how to use in order to get the correct answer. Okay, the second one is the pitot static tube. Okay, earlier it was a dynamic, so now it's a static tube. The pitot static tube combines the tube and they can then be easily connected to a manometer. So tadi ada pitot tube, okay, macam ni, is connected to manometer. So manometer, I hope you still remember chapter 3. Chapter 3 dalam tu kita ada belajar manometer. So ada differential. So if you see here, you have 2 opening 1 here at the sides. Yang ni dia akan connect dengan yang ni sebab is connected, and point 2 is connected to the other side. So manometer ada 2 side. So kalau udara dekat sini tinggi, dia akan push, air akan naik dekat sini. If this air is more, the pressure is more, yang ni dia akan tolak ke bawah, yang ni akan naik. Okay, so try to imagine lah. Okay, so based on this, so we will try to do some measurement. Okay, so measurement dekat sini I just bagi tahu apa yang penting. So if you see here, so you have point A and point B. Point A dengan point B. So point A dengan point B dia sama ke tak? Point A dengan point B, kalau based on your understanding, at same level. At same level pressure sama ke tak? Masih ingat lagi? Sama kan? Point 1 to point 1, if it's the same level and same liquid, same density, dia akan jadi sama. So based on this, PA dengan PB, pressure A dengan pressure B, you boleh jadikan dia sama. Macam itulah you akan dapat equation ni. First you try to find for PA. So PA is actually P2 plus rho g x. Okay, so you just take from here lah, this side. So PA is P2. P2 is here. Okay, so kalau you tengok P2 adalah dekat sini. So the pressure 2 is here. P2 is here. Okay, so kalau you tengok P2, so you just take pressure at here is equals to here. Okay, untuk pressure dalam air, dia lagi dalam dia akan pressure lagi tinggi ke ataupun lagi atas? Lagi dalam. So from here you go down, you akan tambah, right? P2 here plus rho g h. H dekat sini berapa? To reach here, from here to here, berapa dia punya H? From here to this point. Okay, saya explain balik. So you have point here. Okay, so this point is equals to this point kan? Okay, so this is your P2 line. Okay, semua pressure at this same level is P2. Okay, so P2, then you want to find A, pressure A. So what is the formula? P2 plus rho g h. Kan, rho g h kan? H dekat sini berapa? Dari sini ke sini? X. X. Sebab itu you dapat rho g x. Okay, so that is your first equation. So in this case, you need to find PA and PB berapa. So equation for PA and PB baru you boleh jadikan dia sama. Okay, PA, so take from here plus rho g h. H is x. So you dapat yang ni. Untuk PB, so dekat sini, so you ada berapa density dekat sini? Satu adalah density of the air and one more density of the liquid, kan? So dekat sini, so P1, so P1 is here, okay? So P1 plus rho g x minus h dekat sini, x minus h, then plus dengan density of this, so which is your h, kan? So you akan dapat pressure of B. So you already get equation for PA and PB. So you jadikan dia sama, PA equals to PB. So you jadikan yang ni sama, then you can get all this equation. Okay, then at the end you boleh cari based on, you boleh cari velocity based on this formula or this formula, depends on the information given. Okay, so the application will be in the fighter jet. Okay, boleh tengok dekat sini fighter jet, dia ada 2 tube. So boleh tengok dekat sini number 2 and number 3. So number 2 and number 3, so dia ada difference dalam air, ketinggian dia ada different. So ada static tube. So from here, how the fighter jet can determine berapa banyak velocity yang dia pergi. So gunakan measurement ni. So ada 2 pitot tube, gunakan manometer. So try to find sebab dalam tu adalah semua computerized. So computer akan calculate based on this pitot tube application. Okay. So dalam yang ni adalah kapal lah, tengok. So you ada few tubes. So which will be connected to airspeed indicator, and you dalam kapal terbang selalunya ada some kind of mechanism to control lah. So to find out. So kalau velocity terlalu tinggi, dia akan turunkan. So unless you want it to be faster. So boleh tengok dekat sini wing pun ada. Okay, so these are different types of company lah. Okay, so pitot-meter. So pitot tube inside a ship, kita panggil as pitot-meter. So yang ni pun dia connected dengan manometer in order to measure the velocity. Okay, so try do this example. Okay, how to find? Okay, tadi kita dah tahu. Okay, these two equation. So kalau ada highlighter, try to highlight. This one no need lah. So only this. So the formula to calculate your U1. U1 adalah velocity 1. Okay. So it depends on the information given in the question. So macam dalam question ni, a pitot-static probe is used to measure the velocity of aircraft flying at 3000 meter. Okay, ketinggian adalah 3000. Okay, and density is 0.909 kg per meter cube. If the differential pressure, selalunya soalan-soalan ni dia akan bagi differential pressure, so that you no need to find one by one. Dia akan bagi terus. If it say differential pressure, maksudnya P2 minus P1. Okay, so reading is 3 kilopascal. So differential pressure P2 minus P1 is 3000 kilopascal. Okay, determine the velocity of the aircraft. So based on this, so ada dua formula. So depends on the information given in the question. So you determine. So which one? Dia bagi differential density ke ataupun differential pressure. Kalau so dalam case ni dia bagi differential pressure. So you use the second formula. Okay, so you just need to substitute. Okay, so square root of 2 P2 minus P1 over density. So 2 differential pressure is given 3000 kilopascal and density is 0.909. So you just solve this, you will get the velocity of V1 equals to 81.2 meter per second. Faham? Okay, so this is on the calculation side. Okay, untuk application is only on the calculation side, and as I say in test 1, calculation is not given. Okay, the third application is a Venturi meter. Okay, so Venturi meter is like this. So you have 0.1 and 0.2, and you have what we call this. Just want to find the correct word. So they just say a pipe lah. Okay, so a Venturi meter is a device of measuring volume flow rate. So earlier pitot tube or pitot static tube, we measure the velocity. Yang ni kita kira volume flow rate. Volume flow rate in a pipe. So you have the pipe, you nak cari. This is the pipe lah. So this is the pipe, and as you can see, it does a diverging and converging setup. Bentuk dia bukan straight lah. So why they want to make the pipe like this? Sebab kalau pipe dia terlalu panjang, so you will have an energy loss in between. Sebab itu dia ada setup. Kalau you tengok pipe dekat luar pun, pipe air ke from lembaga air kan, ataupun any pipe. So after certain distance, you boleh tengok dia ada converging and diverging. Dia ada macam ni lah. Is to increase back the pressure. So kalau dia akan kalau dia turun dekat sini, pressure akan increase, then dia akan jadi normal balik. So it will like naturally create a push. Sebab dia nak travel a long distance. So cuba bayangkan. So empangan dekat mana? Paling dekat dekat mana? Simple list. Empangan Timataso. How far from here? Katalah berapa kilometer? So at least 30 or 40 kilometers from here. Macam mana air dari sana ataupun dari loji air is supplied to your house? Because of this kind of setup, Venturi meter. After certain distance, dia akan converge and diverge. It will increase back the pressure and supply. After some time, dia akan jadi macam ni balik. Okay, so the setup is the accurate method of flow measurement, as energy loss will be very small. Energy loss will not be there. So kalau you jadikan dia straight, after some time energy will be lost, the pressure akan drop. Kalau pressure drop, you takkan dapat air lah dekat rumah, especially if your house is at the hillside. Air takkan naik. So it must have a pressure. Air boleh naik, but you need to use a water pump untuk dapatkan air. So this is a example of venturimeter. Okay, dalam ni pun dia ada setup. So they are using a continuity equation. Okay, so gunakan continuity equation, they eliminate U2, velocity U2, and they substitute inside the Bernoulli's equation. Okay, so this is the equation, then this is the continuity equation, then you akan dapat. Okay, so this the derivation lah. So you can go through dulu. If you tak faham, you boleh tanya saya lah. Okay, so this is coming from this derivation, you just rearrange. Jadi rearrange untuk jadikan U1. So since U1 square, you jadikan dia square root. Okay. So to get the theoretical volume flow rate, so you want to find the value of Q. Okay, Q. This is multiplied by the area. So U1 times with A1. So this is coming from the continuity equation. Okay, to get the actual volume flow rate, take into the account the losses due to friction. Kalau you nak cari the actual flow rate, you kena kali dia dengan coefficient of volume flow rate, ataupun kita panggil as CD. Okay, CD. So CD times with ideal. So you akan dapat the actual. If you find the actual formula, so this is the actual formula in order to calculate. Okay. So you ganti balik yang ni, you akan dapat this thing lah. Okay, so I will show you the example later. Okay. So all these are just a derivation. Okay, what are the? Okay, so why there's an angle? So tadi I bagi tahu ada angle kan? So I just tell the important stuff. So in the venturimeter, you will have an angle, okay, between 6 to 8 degrees. Wider than this will make more friction, and it will cause more energy loss. Okay, so energy loss. So normally in the venturimeter, kita just set. Kalau you tengok dia ada macam ni. Right, in actual ada tengok kan macam ni. So this is actually a venturimeter. Walaupun dia tak nampak macam, dia nampak macam straight, tapi it's actually there's an angle. Okay, you boleh tengok there's an angle. So over a distance, you will have a venturimeter like this. Okay, venturimeter like this, in order to minimize the friction and the energy loss, and also pressure loss. So energy loss is because of heat. So kalau ada banyak friction, dia akan generate more heat, then the energy will be lost. Kita ada kurangkan lah. So when you have this kind of venturimeter setup, so you can increase back the pressure to almost 80%. Dia tak boleh 100%. Maybe you can have a different setup in order to increase to 100%. But in this case, having this kind of natural setup can increase back the pressure to 80%. Okay. Okay, so you boleh do this example. Okay, so vertical venturimeter measures the flow of oil of specific gravity. So dekat sini dibagi specific gravity 0.82 and has an entrance of 1 to 5 dekat sini at 0.1. So you have 2 point, 0.1 here and 0.2 here. So it's connected to this. So the entrance dibagi tahu dekat sini, the diameter is 1 to 5 millimeter. Okay, throat is 50 millimeter. So you have a throat, bahagian yang kecil. Okay, so you have a smaller place here. Itu yang kita panggil as throat. This is 50 millimeter diameter. Okay, there are pressure gauge at the entrance and the throat. So you letak satu pressure gauge dekat sini and one more here. Okay, so which is 300 mm above the entrance. So maksudnya ketinggian dari sini ke sini adalah 300 mm. The coefficient for the meter is 0.97 and pressure difference is 27.5 kilonewton per meter square. Calculate the actual volume flow rate. Actual volume flow rate adalah Q actual. Okay, tadi kita tengok kan ada Q actual. Okay, so you will try to find. So you have height Z, Z1 and Z2. Okay, first you need to find the area of entrance. So kita cari sebab diameter dah diberi. So you find the area. So you can apply the formula pi d square over 4 ataupun pi r square. So you can get area 1 is 0.01226 meter square. Then you have area 2, area of throat. Tadi entrance, yang ni ada throat bahagian yang kecil. So diameter is given, so you can find area 2. So ini adalah formula value dia. Okay. Then the pressure difference are given, P1 minus P2, 27.5 times 10 to the power of 3. Omega is given. So specific gravity is given 0.82. So omega is specific gravity times weight, gravity times weight density. So you dapat omega adalah 8044.2. Okay, then the difference in height. So difference between this and this is sebab dia naik. So kalau dia turun, it will be plus. Since it is going up, so you letak minus. So minus is indicating that there's elevation. Okay, and CD, because ini dibagi coefficient of the venturimeter is CD adalah device. Okay, device ataupun of the particular equipment. Okay, so CD is 0.97. Okay, then you can find yang formula ini is from here. Okay, sorry, not here. So ada dua formula, satu yang ada density, formula ini. It's actually the same. Okay, so both are the same. Sorry, the same. This Q actual. So you can either use, if the pressure difference is given, you gunakan formula ni. So formula ini saya akan bagi dalam appendix. So tak perlu hafal. Atau kalau diberi density, so you use this formula. So ada dua formula. Okay, so in this case the pressure difference is given. So you just replace all the value. Okay, P1 minus P2 already know, Z1 minus Z2 already know, A1 A2 already know. Semua dah tahu, and CD and A1 pun dah tahu. So meaning all the values you already know. We just need to substitute inside there and you find the Q actual. Okay, Q actual. Okay, understand? These are all replacing the values. Okay, so number 4. Okay, flow through a small orifice of free jet. Okay, ini selalunya dalam kolam air dekat rumah. So in the house you have kolam air kan. Okay, dalam bilik air, so you have, so dekat bawah you letak gabus kan. So normally you want to prevent the water to come out, then you isi air. So untuk you mandi. So ini adalah kolam air. So example lah. So there can be a flow through the small orifice, ataupun kita panggil as free jet. Dekat bawah kalau you buka gabus tu, air akan keluar. So which will create a water jet ataupun free jet. So we consider the flow from a tank through a hole in the side close to the base. Selalunya kita takkan ada lubang ni dekat bawah lah. It's at the particular height. So from free surface to the this opening ataupun kita panggil as orifice is height h. Okay, and here it will be like this, it won't be straight. Dia akan ada sedikit angle lah, that we call as a vena contractor. And you will have the actual flow. Okay, so some of the important stuff from here. Okay, the shape of the hole edges are sharp. So kalau you tengok dekat sini, dia sharp. Kenapa sharp? You want to minimize the frictional loss. So kalau you letak yang ni straight macam ni, so you will have a frictional loss. Sebab more water ataupun liquid molecules akan geser dengan that particular hole. So in order to minimize the frictional loss and minimize the contact between the hole and the liquid particles, so you are making it sharp just at one point. Hanya at that particular point the molecule will have contact, so you will minimize the frictional loss. Okay, so the conversion is called the vena contracta. So kalau you tengok ada convergence dekat sini, so we call as a vena contracta. Okay, so it's a Latin word, it's for a contracted vein. Okay, so at the surface velocity is negligible, sebab dekat surface dekat sini atas ni, so velocity is 0, and pressure, atmospheric pressure pun kita ambil as 0, because both sides are having atmospheric pressure. So yang atmospheric pressure P1 kita ambil as kosong, so P2 pun kosong sebab dekat sini pun atmospheric pressure P2 is 0, and Z1 adalah H. Okay, Z1 adalah H from this hole to here adalah H, and Z2 adalah kosong sebab you now start measure dari sini. Okay, so taking into consideration all these values, so you replace lah. Dekat sini tadi kita ada CD coefficient of the device. Here you have a coefficient of velocity, we call as a CV. Okay, CV, and you have a contraction coefficient, kita panggil as CC. So ada tiga lah, CD, CV and CC. So depends on that kita akan calculate. So the formula is A actual equals to CC times with A orifice. Okay, so all these are just a derivation. Okay, so if you want to find the Q actual, you just can replace inside this in order to find. Okay, another thing that earlier we saw the flow rate. The second one that we can calculate is the time taken to empty the tank. Okay, air bergerak dari atas ni ke sini dalam berapa masa? How long? So we can consider the time taken to empty the tank from level H1 to here to H2. Okay, so Q is negative because the water is dropping, so the H is reducing. Okay, so this is the formula to calculate the actual flow rate. CD times with area of orifice times with square root of 2GH. Okay, we will see the example later. Okay, ini more on the theory side. Okay, and the time taken you boleh calculate gunakan formula ni. So you don't need to derive, you just take this formula, you just gantikan the value. Okay, so try this example. Okay, apa yang kita belajar tadi, so maybe it's confusing because too much info, tapi try to do example, because for your level you just need to know how to apply the values inside the derived formula. So you tak perlu derive the formula. Okay, so try to do this if you want to understand better. Okay, so example number 4. A pressurized tank of water has a 10 cm diameter. Okay, so tank ni adalah 10 cm diameter orifice. So dekat sini 10 cm. So maksudnya diameter dia dekat opening ni adalah 10 cm diameter. At bottom ada dekat bawah, where water discharges to the atmosphere. So atmosphere, the water level is 3 meter above the outlet. So dari sini 3 meter. The tank air pressure above the water level is 300 kilopascal dekat atas ni. So while the atmospheric pressure. So maksudnya dekat atas ni dia tertutup. Meaning is a container. Sebab kalau dia terbuka, dia akan sama dengan atmospheric pressure. Sebab yang ni dia tertutup, so here is 300 kilopascal. Dekat luar ni adalah 100 kilopascal atmospheric pressure. So maksudnya dekat sini atmospheric pressure adalah 100 sebab yang ni dia terbuka. Okay, so that's how you need to understand. So neglecting the frictional effect, determine the initial discharge rate of water from the tank. Jadi disuruh cari initial discharge rate. So kita akan tengok apa itu initial discharge rate. Okay, so this is the Bernoulli's equation. So Bernoulli's equation, so you try to equate, so try to replace. So I bagi tahu tadi, so this is a standard formula and you need to find which one you need to become zero or constant. Okay, so dekat sini, so P1 is not equals to 0. P1 sebab dia dah bagi pressure in the tank is not atmospheric. So kalau it is atmospheric, dia akan jadi kosong. So since it is not kosong, so you need to take into consideration. Then velocity you are having V1 adalah kosong. Sebab dekat atas ni initially velocity tak ada. Sebab dia air static kan. So velocity is 0. Okay, V1. So bahagian ni akan jadi kosong. So Z2 ada air. Ada ketinggian 3 meter. Z2 adalah kosong. Sebab dia sama level dengan ni. Tak ada ketinggian. So Z2 adalah kosong. So you replace all this information inside here, you akan dapat formula ni. So yang bahagian ni jadikan kosong, yang ni pun jadikan kosong. Left this part, this part, this part and this part. So you rearrange, you akan dapat yang ni. So you akan dapat yang ni lah. So if you rearrange. Okay, so after that, so you try to rearrange to find the V2. Okay, so you jadikan semua ni, you rearrange, you get this formula. Then you gantikan formula value. So 2 pressure 300 minus 100, so kilopascal. So density they say is a water, right? So water, so automatic ambil 1000. So unit conversion. Then 2 gravity times weight Z1. Z1 adalah 3 meters. Okay, so you get the velocity 2 equals to 21.4 meter per second. So yang ni adalah, this is not actually V. Okay, so discharge rate. So you can take so V lah, V dot. Okay, so air orifice V2. So you take the formula. So area of the orifice is pi d square over 4 times weight V2. So just ganti yang ni, so you akan dapat the initial discharge rate, so which is 0.168 meter cube per second. Okay, so another example. So dalam example ni, yang ni pun dia satu container, but instead of the water discharging at the side, they discharge dekat bawah. Di bawah, then the water is jet at the side. So dia nak kita cari berapa ketinggian yang dia boleh sampai. Berapa ketinggian yang dia boleh sampai. Okay, so the water level in a tank is 20 meter above the ground. Okay, dari ground adalah 20 meter. So dari sini ke sini. So the hose is connected at the bottom of the tank. So kalau hose is at the side and bawah, dia berbeza. Because it depends on the direction of the water. Sebab tadi dia water dia sama level, so the pressure will be the same. Tapi since it's down, the pressure will have a difference. And the nozzle at the end of the hose is pointed straight up. So they pointed straight up. The tank cover is airtight. So maksudnya udara dari luar tak boleh masuk. And the air pressure above the water surface. Above the water surface is 2 atmospheric pressure. Okay. The system is as a sea level. Okay. Determine the maximum height to which the water stream could rise. Kalau you buka valve dekat bawah ni, berapa banyak, how much the force will be created to push this water, berapa ketinggian dia. Itu yang kita kena measure. Okay, so in this case, so V1 equals to V2 equals to 0 because velocity is in the same direction at bottom of the tank and is negligible. So kalau you tengok water from here to drop and this direction, dekat bawah ni kalau you buka, water akan turun ke bawah ke tepi. Dia akan turun ke bawah. So water ni pun dia bergerak ke bawah, yang ni pun bergerak ke bawah. So this V1 equals to V2. You boleh jadikan dia sama. Okay, jadikan dia sama. So jadikan dia kosong. So maksudnya komponen yang ada V1 dengan V2 ni you jadikan kosong. So yang ni jadikan kosong, yang ni pun you jadikan kosong. Okay. And Z2 is considered since there is height difference. Dekat sini berbanding dari sini ke bawah ni ada height difference. So Z2 you are taking into Z2 you are taking into consideration because there is a height change. Okay, so dekat sini, so P1 ada, yang ni ada, Z2 ada. Okay, Z1 pun ada. So at the end you akan dapat formula macam ni. Okay, so you rearrange the formula, you will get like this. Then yang ni adalah so atmospheric pressure. So dekat sini dia cakap gauge pressure. So you are taking only the gauge pressure. Atmospheric pressure you are not taking into consideration. So you simplify. So Z2 equals to P1 gauge over density of G plus Z1. So you dapat formula ni, baru you gantikan dengan formula dengan values. Okay, so P1 gauge is 2 atm 1000 9.81. So this is your unit conversion plus dengan yang ni 20. So that is your Z1. So you solve yang ni, you akan dapat Z2 equals to 40.7 meters. Meaning if you open this valve, the water will drop and this water will jet up to 40.7 meters. So itu adalah calculation dia. Okay, so another example, so you boleh try buat. Okay, similar. So you take the Bernoulli's equation, standard, kemudian you cari mana yang you akan jadikan kosong, eliminate from the equation. So you derive the equation for that particular application, baru you gantikan value. Okay, so that's how you use the Bernoulli's equation and continuity equation in order to solve the problems. Okay, so example 6, I try to go fast. Okay, so oil of specific gravity 0.82, the discharges from an open tank through the orifice. Kalau you tengok dekat sini, dia ni bukan airtight, so it's open to the atmosphere. Okay, so the orifice is diameter is 14 mm. The coefficient of velocity CV is 0.88 and the coefficient of contraction CC is 0.62. The center of orifice is at the depth of 0.9 meter. So dari sini ke orifice ni adalah 0.9 meter from the surface of the oil. Yang ni adalah oil. Okay. So determine the diameter of vena contracta. So dia suruh cari diameter of the vena contracta and the volume flow rate of oil through the orifice. Dia dah bagi specific gravity of the oil lah. Okay, so the solution, the data given, saya dah letak dekat atas. So find the diameter of vena contracta. So is the area of orifice. The area of orifice. So you dah boleh cari. So it's given the diameter. So this is the area. So CC equals to AC over A0. Dan ni dari equation ni lah. So actual area actual equals to CC over area orifice. So area of the vena contracta adalah A actual. So untuk cari yang ni, so boleh ganti. So CC is given. So you can find the area of the vena contracta. Then you can get this area. From here you boleh cari sebab yang tu adalah bulat. So dari area bulat, so you tahu formula dia adalah pi d square over 4 ataupun pi r square. So dari sini you boleh cari diameter of the vena contracta, which is 11.02. Okay, then they asked to find the volume flow rate of the oil through the orifice. Okay, so theoretical velocity, ini adalah formula yang tadi, V equals to square root of 2gh. So you gantikan value ni, you akan dapat theoretical velocity of 4.0202. Okay, all these are the formulas that you need to use. So try to highlight. So kalau boleh bawa highlighter. Okay, bawa highlighter. Okay, so try to highlight all this formula. So theoretical volume flow rate, so Q equals to VA0. Okay. So ini adalah formula yang ada tadi lah. So in the previous slide, so V theoretical velocity you already get. So area of orifice pun you dah calculate tadi. Okay, based on this you can get the theoretical volume flow rate Q equals to 6.47 times 10 to the power of negative 4. So coefficient of volume flow rate CD equals to CV. Ini pun satu lagi formula. So that you can use in order to find the CD. So you try multiply CV with CC. So you can get CD equals to 0.546. From here you ganti dalam formula ni. So which you already calculate. Actual volume flow rate is CD times theoretical volume flow rate. So which you will get, so you can stop here lah. Kita perlu stop, convert to this. So 3.53 times 10 to the power of negative 4 meter cube per second. So kita perlu convert ke liter per second. Okay. So I think one more example. Try to check again. All this example. Okay, so example 7. Yang ni pun kalau tengok is a open is it a open space? Okay, so it's not given. Yang ni dia suruh cari masa. Tadi kita cari velocity, kita cari pressure, kita suruh cari flow rate. So this one you find a time. How long from here to reach here, the water. Okay, from a tank shown above, find the time required to drain the tank from a level of 3 meters. So level of 3 meter H1 to 0.5. So 0.5 adalah H2 lah. So the tank has a diameter of 1.5 meter. So diameter of this, and nozzle has a diameter of 50. So nozzle adalah bahagian ni lah di J ni. Okay, so based on this, so you can find the area of tank, pi d square over 4. So yang ni boleh cari. So area of the nozzle pun kita boleh cari because it's given. So these are very direct. Then you ambil ratio dia. 80 to AJ is 900. So then you ganti. Formula ni akan diberi so for you to find. So T2 minus T1, the time taken is this formula. Okay, formula ni actually ada diberi tadi. Yang ni. So time taken. But for this, I give a different one lah. Actually, H1 to power of half is actually square root of H1. Okay, so mathematics. Okay, so from here you boleh ganti. Sebab yang ni formula ni dia berdasarkan the ratio of areas. Okay, so you ganti yang ni, so you can get the time taken for the water to from here to reach this level is 417 seconds. Okay, sebab yang ni dia dalam second. The value ni dalam second. So it take 417 seconds for the water tank to drain. Okay, so that is about chapter 4. Saya tahu ada banyak benda yang kita belajar within that 1 hour. So but mostly examples. Okay, examples that you need to try again. So example ni yang dalam lecture note. So try again and you try to understand each step. Okay, so kalau you tahu, so you can ask me during the tutorial. Okay, so I will try to explain. Okay, so any question? So another 2 minutes. Okay, so I try to complete the attendance. Okay, Arif Shazwan. Sorry, Arif Syairan. Arif Syairan ada. Mikail. Muhammad Aikal. Muhammad Aikal. Muhammad Amar bin Roslan. Sukma. Muhammad Faiz. Muhammad Faiz Othman. Yang ni tak ada 3 hari ya, dia akan dapat surah amaran. So bagi tahulah dekat kawan you. Okay, Khairul Azhar. Zahirul Hakim. Zahirul Hakim ada. Nur Aimi Nadira. Nur ada. Nur Fakira. Nur Fakira ada. Ada. Nur Afizatul Akmal. Ada. Nurul Shakira. Parameswaran. Sufyan Davis. Tivagar. Wan Nur Kamarina. Ada? Ada. So okay. So if no question, okay. So as I said, Friday pukul 8 ada quiz. Okay. So try, if you have laptop, try to use laptop. Kalau tak ada, phone pun boleh. So it's more on the quiz side, quiz macam game. Okay, macam game. So we will use application word wall. Okay, so apart from that, I will give chapter 5 as add puzzle for this week. So please prepare for your test 1. So next week cuti, tak ada kelas. So balik itu kita akan ada test 1. So try to prepare chapter 1 until chapter 5. Quiz pun chapter 1 until chapter 5. Okay, and this coming Friday I will give open-ended lab. Okay, for lab 2 and lab 4. So tarikh hantar tu adalah final week. Okay, week number 14. So maksudnya you ada dalam 8 minggu untuk settle 2 lab tu. Sebab lab tu you kena develop the whole lab module and you need to find your experiment and you need to solve. Markah dia lagi tinggi. Okay, so I think that's all announcement from me. So thank you. Okay, sorry. Yeah? Yes, yes, sorry. Stop the recording there.